everyone! Ever felt like you're deciphering a secret code? Well, today, we're cracking the code of arithmetic sequences. These aren't just random numbers. They're a perfectly ordered system, and once you understand the rules, you'll be amazed at how predictable they are.
A sequence is simply an ordered list of numbers called terms. These terms can follow a pattern or be completely random. We often use subscripts to denote the position of each term in the sequence.
Here are a few examples of a sequence. Example number 1. Sequence 1, 3, 5, 7, and 9. This sequence represents the set of the odd positive integers. Notice the pattern? Each term increases by 2. This is called an arithmetic progression, where there is a constant difference between consecutive terms. Example number 2. Sequence 2, 4, 8, 16, and 32. Here, each number is multiplied by 2. This is a geometric progression, where there is a constant ratio between consecutive terms. Example number 3. Sequence 5, 12, 2, 8, 7. This sequence does not have an obvious pattern.
Sequence can be categorized in many ways. We've seen some examples, but let's talk about some common types. Besides random sequence, there are sequences with clear patterns, like those we've already seen. Remember that the key is to look for a relationship between the terms.
Now, let's focus on the special type of the sequence called arithmetic sequence. In an arithmetic sequence, there is a consecutive pattern. Each term is obtained by adding a fixed value to the previous term. This fixed value is called the common difference.
An arithmetic sequence is a special type of sequence where the difference between consecutive terms is always the same. We call this consistent difference, or the common difference.
The common difference is the key to understanding arithmetic sequence. It's the secret ingredients that make them so predictable. It tells us how much we need to add or subtract to get from one number to the next. The common difference, often represented by the letter D, is the constant value added to get from one term to the next. For example, in the sequence 2, 5, 8, 11. The common difference is 3. 5 minus 2 equals 3. 8 minus 5 equals 3, and so on.
To find the common difference, simply subtract any term from the term that comes after it. It's always the same, no matter which pair of consecutive terms you choose.
Now that we understand the common difference, let's learn how to find any term in the sequence using a formula. This formula is your secret weapon for solving arithmetic sequence problems. A sub n is equals to a sub 1 plus n minus 1 times d,
where a sub n is the nth term you want to find, and a sub 1 is the first term of the sequence. N is the position of the term you want to find. D is the common difference. And just in case you need to find the common difference from a list of terms, D is equals to a sub n minus a sub n minus 1, where a sub n and a sub n minus 1 are consecutive terms.
Let's put our formula to the test. We'll walk through a few examples of how to use the formula to find a specific term and arithmetic sequence.
We have here some examples of arithmetic sequences. In example number 1, we have the sequence 3, 9, 15, 21, 27, and so on. Our problem here is to find the 14th term. Now from our given, we have the common difference, which is 6, our first term, which is 3, and the number of terms, which is 14. In our solution, we'll go back to the formula, which is a sub n is equals to a sub 1 plus n minus 1 times d. Now let us substitute all the terms. A sub 14 is equals to 3 plus 14 minus 1 times 6. A sub 14 is equals to 3 plus 13 because 14 minus 1 is 13 times 6. 13 times 6 is 78 plus 3 is 81. Therefore, our 14th term is 81. We have here example number 2, which is the sequence 4, negative 1, negative 6, negative 11, and so on. Our problem here is to find the 18th term. Now our given, we have the common difference, which is negative 5, our first term, which is 4, and the number of terms, which is 18. In our solution, we'll go back to the formula, which is a sub n is equals to a sub 1 plus n minus 1 times d. Now let us substitute all the terms. A sub 18 is equals to 4 plus 18 minus 1 times negative 5. A sub 18 is equals to 4 plus 17 because 18 minus 1 is equals to 17 times negative 5. 17 times negative 5 is negative 85 plus 4 is negative 81. Therefore, our 18th term is negative 81. Now, from our last example, we have the sequence 2, 6, 10, 14, and so on. We need to find the 12th term. Now, from the given, we have the common difference, which is 4, our first term, which is 2, and the number of terms, which is 12. Now, in our solution, we'll go back to the formula, which is a sub n is equals to a sub 1 plus n minus 1 times d. Now, let us substitute the terms again. A sub 12 is equals to 2 plus 12 minus 1 times 4. A sub 12 is equals to 2 plus 12 minus 1, which is 11 times 4. A sub 12 is equals to 2 plus 11 times 4 is 44. A sub 12 is equals to 2 plus 44, which is 46. Therefore, the 12th term in this sequence is 46.
As we've seen, arithmetic sequences are a fundamental concept in mathematics with applications in various fields. By understanding their properties and formulas, we can solve problems and explore patterns in a structured way. I encourage you to continue investigating the world of sequences and series, as they offer a rich tapestry of mathematical exploration.